This is the Chapter 2 test review. What I would like to do is to get a graph of this first before we can match it up. So this is the square root function, and plus 3 makes it move up 3. So our graph would look something like this. It's asking for the domain. So our x values start at 0, and they will keep going on through infinity. So we have including 0 through infinity, which is choice D. Part B, another square root function, but this time it's moving minus 3 on the inside, moves it right 3, so it looks like this. Looking for the range. Range of your y values starts at 0 and goes up through infinity. So 0 through infinity, also D. X squared minus 3, okay, minus 3 shifts it down 3. So there's your graph. Want the domain of this, and domain goes all this way and all that way, so it includes all the numbers from negative infinity to positive infinity, which is C. Okay, x squared plus 3 moves it up 3. Looking for the range. Okay, range, there's no y values until you hit 3, and then there are above 3. So from 3 through infinity, just choice B. Okay, cubed root, it looks like this, with minus 3 shifts it plus 3, so something like this. The domain would be all these x's and all those x's, so every x works, all real numbers, which is C. Cubed root just shifts it up 3. Okay, looking for the range. Okay, this does keep going down, 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 slowly, but surely it does. And this will keep going up, up, up. So once again, it's all real numbers. Part C. Absolute value is a V, minus 3 shifts down 3. And with the domain, so all these x's and all these x's, it'll keep going, going, going. So all x's are included. Okay, absolute value is a V, plus 3 shifts at minus 3. There's our graph. Looking for the range. Okay, no y's down here until you hit 0. So it includes 0, and then keeps going up through infinity. Just choice D. X equals y squared. Okay, that's the same as if you take the square root of both sides. B plus or minus the square root of x, which looks like this. Want the domain, so there's no x values until you hit 0, and then there are x values, so from 0 through infinity. Okay, the range, we have that same graph. The range, all the way down here and all the way up there, should be all numbers, which is C. Okay, number 2. Sketch a graph here. Okay, so part A. Okay, the graph looks something like this. So part A is going to be up 2 units. So everything is going to be shifted up 2 units. So if that's at negative 3, it'd be at negative 1. Okay. Part B, draw the original first. Okay, part B, if the plus 2 there, we'll make it moved left 2. So if this was, what is this? This was at 4, so it'd be at 2. It'd be at negative 2 over there. So something like that. Everything moves left 2. Part C. Okay, part C, negative. The negative out front is reflect over the x-axis. So it will look something like this. D. Okay, the negative on the inside is a reflect over the y-axis. So it'd be looking like this. Okay, E is 2f of x, okay? So what we're doing is every output is multiplied by 2, so it's stretching. So this output of -3 goes all the way down to -6. And this 0 times 3 is still 3, right? So it's still going to go through at that point. Okay, so you can see that stretching idea. I should write that. Stretch times 2. F. Okay, it's the absolute value. So remember, absolute value makes everything positive. So this part will still stay the same, but this part will be positive, so it'll just be reflected like this. So it'll be like that. Okay, that's number 2. Number 3. Okay, we have the point -2, 4. Okay, that point's on there of f of x. Another point, if I have okay, so basically, this is a harder one to define. Basically, to get an don't worry about it. It's going to be -1, 4. We're going to skip that one here. And actually, I shouldn't have assigned 3. We're going to skip this one too, because I haven't talked about this in class. I'll just give you the answer here. -2, 4. The answer is -4, 4. So I might, oh yeah, I didn't actually assign number 3. That's why I didn't assign it. Good. Okay, number 4. And 4, you only had to do part A. You just want to sketch this by hand. So it's a U-shaped, and +4 shifts it up 4. -2 shifts it right 2. And the negative reflects it down. So the graph will look something like this. Okay, and then 5 through 12. Okay, so we have this y equals f of x, this graph here, and then we have another point 36 on there. If it's symmetric across the y-axis, what's another point that's going to be on there? Okay, so I know this point 36 across the y-axis comes over here, which will be -3, 6. Part B, I'm going to have the point 36, and part B is across the origin, so that becomes down here, would become -3, -6. Part C, suppose the graph is symmetric with respect to the y-axis. What would you expect to see? Okay, so if my graph did look something like this, okay, if that was my graph there, okay, from there, I would expect it to look like this, reflected across your y-axis. Okay, number 6. Okay, so briefly explained how you can graph this. Okay, you know it's going to go down 5, it's going to go left 2, and stretch by 4 times higher. Okay, so that's how to do it. Part B, sketch by hand this. Okay, so sketching by hand, it's an absolute value, V-shaped. It's moving up 2. It's going right 3. It's going to open down, and it's compressed, so it's going to actually go down 1 and over 2, and down 1 and over 2. So it's going to be a wider V shape. Okay, and then it's asking us for the domain and the range of that. The domain are all the x's here and all the x's there, so all numbers. The range starts at 2, none above, but is below. So from 2 to from negative infinity to 2. Start with the lower number, right? Number 7. Okay, we got a function here. Where is it increasing? So here's a, from left to right, you can see it increasing. Constant decrease. Okay, so this is the increase part. And that goes from negative infinity to negative 3. It does not include the negative 3. Okay, where is it decreasing? So decreasing here from 4 through infinity. Also not including the 4. C, where is it constant? From negative 3 to 4. Okay, notice closed circles, so we're going to include, that's including those. Where is it continuous? Okay, so it's continuous from negative infinity all the way up through negative 3. And then it jumps, and then it's continuous from negative 3 to 4. And jumps, and then it's continuous from 4 through infinity. Domain of the function. Okay, so all these x's are included here. Negative 3 is included. All these x's are included here. 4 is included here, and all these x's are included there. So all real numbers. What's the range of the function? So our y's. So this will keep going down, 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 but there's nothing above 2. So it's from negative infinity through 2, and it doesn't include the 2. You could also say x is less than 2. That'd be okay as well. Okay. Okay, number 8, we're solving these absolute values. So for part A, we have 4x plus 8 equals 4, and 4x plus 8 equals negative 4. So you solve them. Okay. That's part A. Part B, we have 4x plus 8 less than 4, 4x plus 8 greater than negative 4. Remember, go LA. So since it's less than, it's an and statement. So both things need to be true at the end. So negative 3 is less, greater than negative 3, less than 1. So every number in between here will work. Okay. Part C. Greater than 4, you can't see it, let me shift it over, is less than negative 4. Since the original is greater than, it's going to be an or statement. Okay, negative 3 is less than negative 3 and greater than negative 1. Okay, so there we have our graph. Okay, now let's think about this. They want us to look at this graphically as well. Okay, so if I think about this graph here, we have the absolute value of x plus 8, absolute value of 4x plus. Okay, if you graph the absolute value of 4x plus 8, that graph looks like this. And if you graph y equals 4, it looks like this. Okay, so they are equal to at -3 and at -1. Okay, we're thinking about last chapter stuff here, right? So where they intersect each other is where they're equal to each other. Okay, this one was the absolute value is less than. So where is absolute value of this graph less than this graph? Okay, right in this area, right? Between -1 and -3. And where is the absolute value greater than 4? So here's 4. These have outputs greater than 4. So down below there and above there. It's kind of neat how that all comes together. Okay, number 9. Okay, you can see it here. Okay, we have our two functions. We're going to find f of x minus g of x. So f of x is 2x squared minus 3x plus 2. And we're subtracting the g of x, which is -2x plus 1. So a lot of you probably distribute through that negative and then add like terms. Okay, so you get your answer there. Part B, I'll put part B over here. We're dividing them. So it's just your f of x function divided by your g of x function. And for our purposes, we're not going to simplify that. We'll just leave it there. Okay. Part C, domain of f divided by g. Okay, so I would get a graph. So I'm going to pause this, graph it on Desmos. Okay, in graphing it in Desmos, it looks like this. Okay. So we haven't talked about this year. You might have in Algebra 2 last year, depending. So what you do to find your domain is if you set this equal to 0 and you solve this, you get x equals 1/2. So what happens here is there is an asymptote at 1/2 here, where these get closer and closer and closer but never touch. Because if I put a 1/2 in here and I evaluate this, that would be dividing by 0. You can't divide by 0, that's why it's undefined. So our domain, you could write it as all real numbers, but x cannot equal 1/2. Or you could say it goes from -infinity to 1/2, and from 1/2 to infinity. Okay, D, we're finding f of g of x. Okay, so we're taking the g function, plugging it into the f function. Okay, so if we look over here, taking this g function, going to plug it into that f function there. Okay, so we have 2, plugging in the g function here, minus 3, plugging in the g function, whoops, plus 2 in the end. Okay, so we want to evaluate this now. So this is 2x minus 1 times -2x plus 1 times -2x plus 1, which is 4x squared. Minus 2x and minus 2x is minus 4x. 1 times 1 is 1. I'll distribute through that a while as well. That's plus 6x minus 3 plus 2. So 8x squared minus 8x plus 2 plus 6x minus 3 plus 2. 8x squared minus 2x plus 1 when you combine your like terms together. Okay, E, we're doing the f of x plus h minus f of x divided by h. Okay, so we're going to find that here. So we are doing the f function, so we're just using the f function here. Okay, so that is going to be plugging your x plus h in right here, right? 2 times x plus h squared minus 3 times x plus h plus 2. And we have to subtract the f of x function, which is 2x squared minus 3x plus 2. And then the whole thing is divided by h. Okay, so we got to square this. So x plus h would be x squared plus 2xh plus h squared. Distribute this through, would be 3x minus 3h plus 2. Distribute the negative through, negative 2x squared plus 3x minus 2. All divided by h. Distribute that through, 2x squared plus 4xh plus 2h squared, and the rest of this. All right, now we combine our like terms. 2x squared minus 2x squared. Negative 3x, positive 3x. Plus 2 minus 2. Okay, so we have 4xh plus 2h squared minus 3h, all divided by h. And if we divide an h out of all of them, we have 4x plus 2h minus 3. Okay, number 10. Okay, we have this piecewise function we want to graph by hand. So negative x squared plus 3 for less than or equal to 1, so at 1. We know it's going to shift up 3, and we know it's opening down, so it's going to look something like this. Okay, let's find some points though. Let's plug in a 1. So 1 squared is 1, negative 1 plus 3 would be 2. Plug in a 0, 0 squared is 0 plus 3 is 3. Plug in a negative 1. Negative 1 squared is 1, negative 1 plus 3 is 2. Okay, let's do one more yet, 2. 2 squared is 4, negative 4 plus 3 is negative 1. Okay, so you can get that defined U-shaped out of it there. Okay, and that's what we're equal to there. Cubed root is, we know, looks like this, right? Cubed root looks like that. And it's going to be shifted up 2, okay, for greater than 1 though. So let's go with, let's see where it's at 1. Cubed root of 1 is 1, plus 2 is 3. Okay, what's the next number that's easy to find the cubed root of? Well, 8, okay, probably. 2, 3, 4, 5, 6, 7. Let's find an 8 here. Okay, when x is 8, cubed root of 8 is 2, plus 2 is 4. Okay, so that's going to come up like through here, and then go out like this. Okay, so it looks something like that. And you can use the graphing calculator Desmos to check that then. Number 11. A certain long-distance carrier provides service between Podunk and Nowheresville. X represents the number of minutes, and x has to be greater than 0, right? So we haven't talked about this one lately, but this is the greatest integer function. Remember, the greatest integer is it goes to the integer less than that. So if it's at 2.1, goes down to 2. 2.8 goes down to 2. 3 point whatever goes down to 3. Okay, so that's what the integer is. So we want to graph this function. Okay, so anywhere from 0 to 1 minute. Okay, so this is our minutes, and this is our cost. So anything, even if it's like half a minute, well, half a minute would round down to 0, right? So 0 times 40 is 0, plus is 0.75, right? So anywhere up to a minute, not including a minute, would be 75 cents. Okay? Now, from 1 minute to 2 minutes, Okay, if it's 1.5, it rounds down to 1, right? 1.9 runs down to 1. So 1 times 40 is 40 cents plus 75 cents gives us $1.15. So at 1 minute all the way up to 2 minutes, not including 2 minutes, it's at $1.15. That's how much the call is. Okay, from 2 minutes to 3 minutes, okay, we're going to add another. So at 2.8, okay, it rounds down to 2, but still here. So 2 times 40 is 80. And 80 cents plus 75 cents is 60 cents. I'm sorry, that's multiplied. 80 cents plus 75 cents, yeah, $1.55. So we'd be up here at $1.55. At 2 minutes all the way up to 3 minutes, but not including 3 minutes. Okay, and it would just keep going, adding 40 cents in each time. So that would be the graph. Okay, part B, estimated call that is 5.5. Okay, at 5.5, the greatest integer of 5.5 is 5. So we'd have 40 cents times 5 plus 75 cents. So 40 cents times 5 is $2, plus 75 cents is $2.75. Okay, last problem, number 12. Okay, we're making bobblehead dolls. And his initial cost for factory startup supplies, whatever, is $3,300. And each one costs $4.50 to make. Okay, so our cost function. Okay, it costs $4.50 for every item. And there was an initial startup cost of this much money. It's part A. Part B, find the revenue if each one sells for $10.50. So we're bringing in $10.50 for every bobblehead. Okay, our profit will be how much we bring in minus how much the costs are. Okay, so when you that minus that would be $6 and minus $3,300 yet from our initial costs. Okay, part D, we want to make a profit. So when is that 6x minus 3,300 going to be greater than 0? And 3,300 divided by 6 is 550. So it has to be greater than 550. Okay, so we'd have to sell 551 to make a profit. Okay, and then it says to support it graphically. Okay, basically, if you think about our cost function here, it would start way down here. We're in the hole at 3,300, but it's going to increase at $6 for every doll we make. And out here at $550 is where we break even, and then this is where we start making a positive profit. Down here we're making negative money, up here we're making positive money. Okay, so that is the test review.